This is going to be a quick demonstration for the Forrest Manufacturing Model 480i horizontal blade bandsaw. This has a powered traveling table. This saw was built to order for a specific customer. Customer manufactures these large plastic boxes. They're direct burial conduit and junction boxes, and they want to be able to cut them horizontally from tall boxes into shorter boxes. So this is their specific machine, so I was going to go over the features and do a quick demonstration video. As I said, horizontal blade, traveling table. The blade height can be adjusted manually with a hand crank. Can you see me over here? It's got a hand crank over here. We haven't greased everything up yet. We haven't painted this machine either. Anyway, you've got a hand crank there to raise and lower the blade. It has an electronic digital readout to show you where you are. It's not meant for frequent changes, but it is easy enough to move the blade up and down to match a specific necessary cut height. The table, traveling table, is powered. Variable speed, runs off an AC inverter for speed control. I'll show you the control panel in a moment, but we have two speed controls, one for the forward, one for the reverse. I believe the working blade length on this one is a nominal 50 inches. We size these machines on nominal foot width. Actually, this was a nominal 5 foot width, so 60 inches the nominal. The table is actually 2 inches wider than that, so this is a 62-inch table, and the actual working blade length between the blade guides and the dust nozzle is 64 inches. Machine has all roller blade guides. It has a dust nozzle there for collecting a dust collection system. Blade wheels. The blade drive motor is a 5 horsepower brake motor, set up for 3-phase power. We've got the customer's workpiece locked in here with magnets. A quick and easy way to set these machines up for a cut: put your first workpiece down, put magnets down to serve as a temporary fixture, and depending on how you put them in, the magnets can stay and you can lift the workpiece out. You can just leave the magnets there, put succeeding workpieces of the same shape in without having to rearrange the magnets. Then when you want to change workpieces, just change out the magnets. I also have customers who will either weld or drill and screw into the steel table surface to make a more semi-permanent or even permanent fixtures to hold their workpieces. But the table surface is 12-gauge steel. It's supported with a 2-inch steel framework of tubing, so it's quite stout. Capacity on this one's probably overrated for the application. It's about a 2,000-pound table, way more than the customer needs, but more is good. Let's see. Control panel's all the way over here. You can probably not be able to see it very well in the video, but we have this control panel mounted on a separate stand on about a 15-foot umbilical, so you can run the machine entirely without being near it. I believe this customer intends to put a fence all the way around the machine with access doors, and then they can tie in the access door normally closed switches to the saw panel and turn off the saw if they like. Controls. The blade speed on this machine is a fixed speed. You've got a saw start and a saw stop. No surprise what that does. Blade tension and detention is controlled from here. The blade tensioning mechanism on this machine is a pneumatic air cylinder controlled system. You can tension and detension the blades from here, and when the blade is detensioned, you get a blade fault. Blade fault condition exists anytime the blade is not properly tensioned. We won't let you start the saw if the blade is not properly tensioned. If you do not have air pressure to the saw, say plant air is down, you don't have air pressure, you get the fault. Or if the blade breaks, you get the fault. Table control, you got a table forward and reverse button. One stop button stops it all. That just controls direction. We have two potentiometers, one for the forward speed, one for the return speed. Generally what my operators do, or my customers do, is they'll find some forward speed that works for them, 20, 25% of full speed, whatever it is, but they'll set that speed and leave it. The reverse or return speed, they just leave it at 100%. The idea being, when you're making your cut, your cycle time includes loading the workpiece, making the cut with the table moving perhaps slowly, remove the cut workpiece at the far end, and return the table to the home position. Well, to keep your cycle time quick, your cycle time short, you're always going to return the table to home position at the maximum speed. But I do give you the option of controlling that if you like. The inverter controls the table drive. I have it set up at a maximum speed of 60 Hertz. Gives a maximum table speed of around 2 inches per second. But based on application, if it works out for the customer, they can increase the maximum inverter output frequency to 90 or even 120 Hertz to accelerate the maximum workpiece or table return speed. We have it set at a fairly conservative number now, but there is room to play with that. As far as cutting this workpiece, this is bolted together from separate pieces, and it's got bolts and screws and other hard bits in it. So I've picked a spot where I think we are going to miss all that just by eyeball. I think. Let me double check that. I saw some more screws I didn't realize. Let's crank it down a little more. This thing's just full of screws. Let me work the blade up a little, the workpiece up a little closer to the blade. I'll zoom in for the actual cut. First time I cut something, I usually start with a forward speed at 0. Press the table forward button. Then I'll increase the forward speed potentiometer to whatever speed I want. It's about half speed right there. And I think I'm going to miss all the hardware there. So I'll zoom in a little for you. Telephoto, as the old timers know it. Start the saw. Again, I'll start the table at 0. It's worth pointing out, we have the workpiece oriented, cocked over a bit, 10, 15 degrees, whatever. The idea being to catch a corner of the workpiece instead of just catching it flat. A little flutter on that blade. So we'll go forward, advance the workpiece. Oh, I needed more magnets. I'm going to back the speed down a little bit here. We should have used more magnets. That thing pulling apart. My limiting factor on this table advance speed right now is the fact that I didn't use enough magnets to secure the workpiece. It's trying to get away. But I'm in the meaty part, I'm in the easy part of the cut now, so I'll accelerate the cut. That's about half speed. I will slow down for the back side since my workpiece is going to try to move on me. I'm going to slow down as we break through the back wall. Just that easy. When the table reaches the full end of a stroke, let it run to the end of a stroke there. I like to run the table well clear of the blade, even when it's not moving. It's the end of a stroke, table stops automatically. Stop the saw. And there's your cut. Just that easy. With a little bit more secure workpiece fixturing, it got a lot faster than that. That's the Forrest Model 480i.